This video focuses on preparation and chemical reaction of alcohol. If based on this slide, right, you notice there are 4 methods to prepare alcohol. First, hydration of alkene, hydrolysis of haloalkene, addition of Grignard reagent to carbonyl compound, and fermentation. Actually, based on here, right, 3 methods you learned already. Let's check one by one. Okay, the first one, hydration of alkene. So if you check here, right, actually it's carbon-carbon double bond react with acidified water and then it forms alcohol. Okay, still remember, this is electrophilic addition reaction. So hydrogen ion and hydroxide ion will be added to the carbon-carbon double bond, and then we have to follow Markovnikov rule. Still remember what is Markovnikov rule? The electrophile means H+, okay, will be added to the carbon with greater number of C. So there are greater number of hydrogen. So there are 2 hydrogen over here and 1 hydrogen over C2. So meaning that hydrogen is added to C1 and hydroxide is added to C2. So 2 propanol is formed. Okay, next. Okay, haloalkene, which we learned in previous chapter, react with sodium hydroxide. Aqueous is a strong nucleophile. So it will undergo nucleophilic substitution and then OH will be replaced the halogen. So it forms ethanol. Okay, the third, so this is the second method, hydrolysis of haloalkene, okay, nucleophilic substitution. And then the third is addition of Grignard reagent to carbonyl compound. First, we need to form the Grignard reagent. Do you still remember how to form the Grignard reagent? Let's recall a bit. Okay, it's from haloalkene. So based on here, we are using methane. So chloromethane react with magnesium. Okay, and then with dry ether solvent, dry ether, and then it forms CH3 MgCl. So this one is the Grignard reagent. The former name is methyl magnesium chloride. So when the Grignard reagent react with the methanol, okay, hydrolyze, it will form primary alcohol. Okay. If you still remember, right, previous lesson, madam teach you all, this one is partially positive and then this one is partially negative. The carbon is partially negative, but in this case, the carbon is partially positive when compared with oxygen atom. So this is partially negative. So OMG, attach here, OMgCl, O negative, NgCl positive, and then here, this carbon will attach to this carbon. And then hydrolyze it, and then it will form the alcohol. Recall a bit. And then when Grignard reagent react with aldehyde accept methanol, for example, ethanol, propanol, butanol, it will form secondary alcohol. Okay, you must understand the mechanism for the reaction between the Grignard reagent with the carbonyl compound in order to help you check the attachment. Okay, the attachment from the Grignard reagent with the carbonyl compound. Please take note, because sometimes, right, the question might give you a alcohol and then ask you to split the Grignard reagent and the carbonyl and then check what is the haloalkene and what is the carbonyl compound. So this concept is very important. And then the third one is the Grignard reagent react with propanol. In this case, propanol actually, as long as Grignard reagent react with any ketone, it will produce tertiary alcohol. Okay, the fourth method is more biological way, is from glucose react with yeast with the catalyst Z-mase. It will form ethanol and carbon dioxide. Next, we go for the chemical reaction of alcohol. So there are 1. The first one is the reaction between alcohol with sodium. So it will form O negative and A plus. Okay, the negative positive sign insists, and then the byproduct is hydrogen gas. O negative and A plus. And then the second one is esterification. It's a reaction between alcohol and carboxylic acid. Okay, over here, right, water will be eliminated. The H is from alcohol, and then the OH is from carboxylic acid. And then, so normally, right, okay, I will encourage you all write down the carboxylic acid first, CH3, and then here C, double bond, O. So the attachment is from the O, from the alcohol, O, and then form CH2, CH3. Get it? Okay, I take the CH3C double bond O from carboxylic acid first. So here is from carboxylic acid. And then another side over here is from alcohol. So it forms as the C double bond O COC. Still remember? So this is the functional group of ester, which is carboalkoxy. Okay, and then don't forget the reagent is concentrated H2SO4 heat and then reversible. Okay, the third chemical reaction. Quite familiar, right? Alcohol, alkene. One of the preparation of alkene. When alcohol react with concentrated H2SO4 heat, and then it will form alkene. So this is elimination reaction. Okay, I hope you all still remember. Have to base on Sagev rules. Sagev, still remember what is Sagev rules? Okay, you have to identify when the carbon-carbon double bond is formed, we have to identify which one is the major product. The highly substituted one is the major product. Okay, if the question asks you what type of reaction, the type of reaction is elimination. Okay, next, substitution. Substitution actually quite simple because we are using the halogen. Okay, so for example, HBr, PBr3, PBr5. Okay, all will give the same product, CH3, CH2Br. But you have to be careful about the byproduct because sometimes, right, the byproduct and the major product will be given and then ask you identify what is the reagent. Okay, what is the reactant? So over here, okay, we have to take note where PBr3 react with alcohol, it will form H3PO3 byproduct. When react with PBr5, it will form POBr3 byproduct. Okay, of course, the HBr, PBr3, PBr5 can be replaced by Cl as well. That's why when alcohol react with thionyl chloride, SOCl2, okay, it will form the haloalkene and SO2, HCl, SO2. When there is a SO2 byproduct, meaning that it react with thionyl chloride, SOCl2. So this is substitution reaction. Okay. And then the fifth one, okay, something new for you all, oxidation. Okay, we have to check for the reagent as well. Okay, for primary alcohol, when it reacts with PCC CH2Cl2. Okay, what is PCC? The name of the PCC is pyridinium chlorochromate in dichloromethane. Dichloromethane is the solvent. It will form aldehyde because PCC is a weak oxidizing agent. Okay, and then when it reacts with the acidified potassium permanganate, okay, this one actually you learned already in chapter 5, hydrocarbon, strong oxidizing agent, KMnO4, okay, common H plus heat. This is oxidizing agent. Of course, there is another oxidizing agent, K2Cr2O7, okay. The name is potassium dichromate, and then it will form carboxylic acid. So check for here. There are three example for three strong oxidizing agent. Example, KMnO4, K2Cr2O7, and Na2Cr2O7. All will form carboxylic acid when the primary alcohol react with the strong oxidizing agent. If weak oxidizing agent, aldehyde. Strong oxidizing agent, carboxylic acid. Okay, this is for primary alcohol. And then for secondary alcohol, when it reacts with the strong oxidizing agent, it will form ketone. Okay, you have to take note of what is the color of the sodium dichromate. The color of the sodium dichromate solution is orange color, and then it will turn to green color. Same for the primary alcohol, also will turn the orange color of chromic acid to green color as well. Okay, the chromic acid is referred to Cr2O7. Okay, and then tertiary alcohol, and then no observable change. So the orange color of chromic acid solution remain unchanged. So the observation is no observable change. So you have to take note. Okay, different class of alcohol will give different result towards oxidation test. But the most obvious one, normally the question will ask about this one. Okay, when this alcohol react with potassium dichromate solution or sodium dichromate solution or potassium permanganate solution, okay, the color of the solution remain unchanged, showing that this is tertiary alcohol. Okay, next, about chemical test. Okay, the name of this test is Lucas test. The function of Lucas test is to distinguish between primary, secondary, and tertiary alcohol. Okay, the reagent is concentrated HCl zinc chloride. Okay, so this is the way to write down the reagent. And then for primary alcohol, okay, we check for this C, attached with 1C, so it's primary alcohol. So it won't change the solution. So does not form cloudy solution. Does not form cloudy solution after heating for 10 minutes. Or you just write down, does not form cloudy solution after 10 minutes. Acceptable. And then this is secondary alcohol. You check for this C, attached with 2 carbon. So when secondary alcohol react with the Lucas reagent, it will form 2 layers. At the same time, cloudy solution will be formed, and then within 5 or 10 minutes. If tertiary alcohol, you check for this carbon, attached with 1 carbon, 2 carbon, 3 carbon. So this one is tertiary alcohol. When tertiary alcohol react with the concentrated hydrochloric acid zinc chloride, right, it will form 2 layers. At the same time, the cloudy solution appear immediately at room temperature. So this is the chemical test to differentiate between primary, secondary, and tertiary alcohol. Okay, so make it simple, right? This one, primary alcohol, no cloudy solution is formed. Secondary alcohol will form cloudy solution within 5 minutes or 5 to 10 minutes acceptable. And then tertiary alcohol will form cloudy solution within immediately. The keyword is immediately. Okay, take note. Tertiary alcohol, when react with Lucas reagent, the cloudy solution will form immediately. So the observation for this Lucas test is cloudy solution. And then the timing of the cloudy solution to form. Okay, after Lucas test, another test is Iodoform test to identify methyl carbonyl group. Okay, what means by methyl? Methyl means CH3. Carbonyl means the carbon that attached to CH3 and OH. So this is methyl carbonyl group. So we are using iodine, basic iodine means iodine in sodium hydroxide. Okay, if you are using iodine / OH, it will form the CHI3. Okay, the downward arrow is referred to precipitate. So this triiodomethane is yellow precipitate. Okay, if you are using, okay, for some time this I2 / NaOH negative. Okay, actually no NaOH negative because by right just NaOH. So okay, nothing. So just OH. So it will form, this is the product CHI3 and then O negative and Na plus. You check the difference here. If you just write down OH negative and then it form O negative. If you write down NaOH, it form O negative and Na plus. And then the main product is this one, CHI3 precipitate, CHI3 precipitate, so yellow precipitate. If there is no methyl carbonyl group, you look at this alcohol. Okay, this alcohol and then this carbon not attached to methyl carbonyl. This is not methyl carbonyl. Okay, this one not methyl carbonyl. That's why no observable change. So no yellow precipitate is formed for the negative result. Okay, in general we call it as Iodoform test as well. Okay, next, chemical properties of. Okay, there are 4 chemical properties for phenol. The first one, react with sodium. So as usual, this alcohol, okay, will replace Na will be substituted over here and then form O negative and Na plus, and the byproduct is hydrogen gas. Okay, with ether solvent. Another one is phenol react with sodium hydroxide. Okay, it will form O negative and Na plus as well. So this, and then form the byproduct is H2O because phenol is acidic compound. Okay, please take note. Just now alcohol can react with sodium, but alcohol cannot react with sodium hydroxide. Means the aliphatic alcohol. Okay, if you forgot already, never mind, I just show you. So for example, just now CH3, CH2OH can react with sodium. Okay, and then form CH3, CH2, O negative and A plus and hydrogen gas. But okay, CH3, CH2, OH, the ethanol, if react with sodium hydroxide, So there is no reaction happen, no reaction. Okay, because ethanol not basic. Ethanol no basic properties, sorry, ethanol no acidic properties. Okay, not acidic properties. Phenol, yes. Phenol has the acid properties. We are going to learn soon in chapter carboxylic acid. We have to compare the acidity. Okay, for phenol, carboxylic acid, ethanol, and so on. Aliphatic alcohol cannot react with sodium hydroxide. It only can react with sodium. Okay, next, there's another identification test for phenol. The first one is using aqueous iron chloride. It will form, okay, you just shoot, okay, copy everything and then just FeCl3. So purple complex is formed. So this is the observation for phenol when react with aqueous iron chloride. Another one is react with bromine, okay, aqueous, okay, or bromine slash H2O. It will form 2, 4, 6 tribromophenol. So white precipitate will be formed.